It's time for Math with Mr. Young. Lesson 111, Dividing in Scientific Notation. Let's begin with a power-up. You can use the worksheet provided, or simply pause the video and use a blank sheet of notebook paper to answer the problems on your screen. Go ahead and pause now, and resume once you've completed all of the problems in this power-up. In this power-up, we get to review adding, subtracting, multiplying, and dividing numbers and variables. First, we have 6x plus 2x. To solve expressions like these with variables, the way I try to make sense of it is to put something concrete in place of the variable at first. So instead of saying x, I'd give it some concrete value. Let's imagine that x is an inch. If we had 6 inches plus 2 inches, that would be easy, correct? It would just be 8 inches. So 6x's plus 2x's is also easy. It's just 8x's, or 8x. And there's your answer. This next problem is just as easy as before. 6x minus 2x. Let's imagine something concrete for this variable. This time maybe x is a foot. 6 feet minus 2 feet would be easy, right? It's just 4 feet. So 6x minus 2x is 4x. And that's the answer. Our next problem has 6x times 2x. For this kind of problem, it also helps to think concretely first. Let's imagine that x means centimeter this time. So I start with 6 centimeters. If I were to double my 6 centimeters, I would have 12 centimeters. So 6 centimeters times 2 would be 12 centimeters. That means that 6x times 2 would be 12x. But that's not what the problem says, is it? In the problem, we're not just multiplying by 2, which would mean doubling, we're multiplying by 2x. So we can't just think of 6 centimeters multiplied by 2, we need to think of 6 centimeters multiplied by 2 centimeters. Can you think of anything that is measured 6 centimeters by 2 centimeters? How about a rectangle that is 6 centimeters long and 2 centimeters wide? To find the area of this rectangle, you'd multiply the 6 centimeters by the 2 centimeters. And what's the result? Our result is 12 centimeters squared. 6 centimeters times 2 centimeters is 12 centimeters squared. So our 6x times 2x must be 12x squared. There's our answer. The next problem features division. 6x divided by 2x. To solve this one, I want you to remember that whenever you have something in the numerator and the denominator, they cancel out. Here we see x in the numerator and in the denominator, so we can simply cancel those two x's. That leaves us with 6 over 2. You can solve 6 over 2, can't you? 6 divided by 2 is 3. Our answer is 3. Our next problems will be similar to these first 4, but they will now have more variables. This won't change how we solve them. Up first, we have 9xy plus 3xy. Remember that adding 9 something plus 3 of that same something just gives us 12 something. So 9xy plus 3xy will give us 12xy. Pretty easy, right? Our next problem trades addition for subtraction. 9xy minus 3xy. Again, 9 of something minus 3 of something would simply be 6 of that something. So 9xy minus 3xy will simply be 6xy. That's the answer. Now we have multiplication again. 9xy times 3xy. This time, I'm going to show you a shortcut on how to solve this. You can think of 9xy as being 9 times x times y. So write it that way. You can also think of 3xy as being 3 times x times y. Write it out that way as well. Now, using the commutative property of multiplication, which is just a fancy way of saying that you can move the numbers and variables around, let's group the constants together and the different variables together. 9 times x times y times 3 times x times y becomes 9 times 3 times x times y times y. Remember, any number multiplied by itself is that number squared. So x times x here is x squared. The same thing goes for this y times y. That is y squared. So now all we have left is 9 times 3, which is 27. So our answer is 27 x squared y squared. Nice job. Now we have division again. 9xy over 3xy. Just like our last division problem, let's cancel. X on top cancels with x on bottom. Y on top cancels with y on bottom. That leaves us with 9 over 3. 9 divided by 3 is 3. That's our answer. Next up, we have x plus y plus x. To figure out how we're supposed to solve, let's imagine something concrete for our variables again. Let's imagine that this x is a foot and this y is an inch. If this problem was a foot plus an inch plus another foot, it would be pretty easy to find the answer. The answer would be 2 feet and 1 inch. Something to notice here is that simply saying a foot or an inch is the same thing as saying 1 foot or 1 inch. A foot plus an inch plus a foot is the same thing as saying 1 foot plus 1 inch plus 1 foot, which is why our answer is 2 feet and 1 inch. Let's apply this to our problem. X plus y plus x is the same as 1x plus 1y plus 1x. 1x and 1x can combine, just like 1 foot and 1 foot combined. It becomes 2x. So our answer is 2x plus 1y, or simply 2x plus y. Our next problem is similar, but has subtraction in it. X plus y minus x. Once again, let's imagine this problem with feet and inches. A foot plus an inch minus a foot would be what? Well, let's put in our implied ones. This problem wouldn't change if we said 1 foot plus 1 inch minus 1 foot. What's 1 foot minus 1 foot? 0 feet. So our answer would be 0 feet plus 1 inch. You don't have to say the 0 feet part, so we can erase that. Our answer is simply an inch. Now, let's go back to our problem. First, add in the implied ones. 1x plus 1y minus 1x. Subtract this 1x from this 1x. 1 minus 1 is 0. So our answer is 0x plus 1y. We can simplify this to 1y, or just y. Now, on to multiplication again. X times y times negative x. Remember a previous lesson where we learned about multiplying negatives. When multiplying a bunch of numbers or variables together that include negatives, first do the multiplying and worry about figuring out whether the product is positive or negative at the end. Here we have x times y times x. X times x can become x squared. So our product is x squared times y, or x squared y. Now, should our answer be positive or negative? Well, if the number of negatives being multiplied together is odd, then our answer must be negative. And we have one negative, which is an odd number. So this answer will be negative x squared y. Now, on to division. X times y over x. Hopefully you remember that, to solve this kind of problem, we can cancel. The x on top and the x on bottom cancel each other out. We're left with just the one y on top. So our answer is y. Way to go! Now the problems get a little bit trickier. Up first, we have 3x plus x plus 3. To solve this one, I want you to think about what you learned in a previous lesson about like terms. Do you see any like terms here? Remember, like terms are terms with the same variable part. The variable part of 3x is x. The variable part of this x, which is also 1x, is x also. So these are like terms, and we can combine them. 3 of something plus 1 of that same something is 4 somethings, so 3x and 1x combine to become 4x. We can't do anything to simplify this 3, so we just leave it as is. Our final answer is 4x plus 3. This next problem with subtraction works the same way. 3x minus x minus 3. Once again, find the like terms. 3x and x are the like terms, just like in our previous problem. This time, the problem is asking us to subtract 1x from 3x. 3 minus 1 is 2, so 3x minus 1x is 2x. Once again, we leave this constant as is, and so our final answer is 2x minus 3. Now multiplication. 3x times negative x times negative 3. We're multiplying negatives again, so do the multiplication part first, and we'll worry about whether the answer is positive or negative at the end. Something to remember here is that when we're multiplying, you might want to write out 3x as 3 times x. So, disregarding the negatives for now, we have 3 times x times 3. Hopefully you remember that this x times x can become x squared. Now we multiply this 3 times 3 to get 9. So far, we have 9x squared. Let's see if our answer is supposed to be positive or negative. Back here in the problem, we had a negative here and a negative here. That's 2 negatives, which is an even number. That means our answer is going to be positive. So our answer is positive 9x squared. Finally, we have 2x times 8xy over 4y. For this problem, which has multiplication and division, it will help you to write out 2x, 8xy, and 4y in this way. 2x becomes 2 times x. 8xy becomes 8 times x times y. And 4y becomes 4 times y. Now, let's use the commutative property to do a little rearranging. Let's group the constants together up top. Let's also bring the x's next to each other. So now our problem reads 2 times 8 times x times y over 4 times y. Let's first multiply this 2 and 8 together to simplify that part. 2 times 8 is 16. Now, notice that there is a y on top and a y on bottom. Those y's cancel out. Also, we can pull a 4 out of the top and the bottom. 16 divided by 4 is 4, and the 4 on the bottom divided by 4 is 1. So 16 over 4 simplified to 4 over 1. Now we have 4 times x on top, and 1 on the bottom. We don't need the denominator anymore, because anything divided by 1 is just itself. So now we have 4 times x times x. X times x becomes x squared. That leaves 4x squared. That's it, we did it. Okay, pull out your notes page. Today's lesson is on dividing while using numbers that are in scientific notation. As we discussed in an earlier video, the reason scientists use this special notation is because they are often dealing with very big or very small numbers. And, of course, those scientists are going to have to be able to manipulate those numbers in that notation, so they don't have to convert back and forth to standard form while solving problems. Let's look at a situation where this might prove useful. Let's consider some really big distances, like, say, the distance between the Earth and the Sun. This distance here is about 93 million miles, or 9.3 times 10 to the 7th miles in scientific notation. This number is so large that scientists invented another unit to describe it. They call it an astronomical unit. One astronomical unit, or AU, is the distance between the Earth and the closest star, which is the Sun. And this measurement is used to describe other distances in the universe, so we can get a feel for their bigness. The distance to the next closest star, for instance, is about 300,000 AU, or 300,000 times farther away than the Sun. Something much closer might be the planet Uranus. What if someone told us that Uranus is approximately 1,860,000,000 miles away from the Sun, which would be written 1.86 times 10 to the 9th in scientific notation? And what if we wanted to get a feel for how much further Uranus is from the Sun than Earth is? One way to do that might be to convert 1.86 billion miles into astronomical units. How would we do that? Well, that would require us to create a unit multiplier that converts miles to astronomical units. I already mentioned that an astronomical unit is the distance between the Earth and the Sun, which is approximately 93 million miles. So we can use 93 million miles, written as 9.3 times 10 to the 7th miles, and 1 astronomical unit to form our unit multiplier. Remember, we're wanting to convert from miles to astronomical units. That means we'll want the miles to cancel out, so we need to put the miles on the bottom of the unit multiplier, and we'll put the astronomical units on the top. Now we multiply 1.86 times 10 to the 9th times our unit multiplier, which is 1 over 9.3 times 10 to the 7th. This is the same thing as dividing 1.86 times 10 to the 9th by 9.3 times 10 to the 7th. So now we have a problem that involves dividing numbers that are in scientific notation. How do we solve this? Well, the easiest way is to do it in two parts. First, divide 1.86 by 9.3. I'll give you a second to do that calculation on some scrap paper. Hopefully, you got 0.2 as your answer. A quick way you might have used some mental math would be to notice that if you multiplied the 1.86 by 10 and got 18.6, then that number would obviously just be twice as big as 9.3. So then you could take that 2 and divide by 10, getting 0.2. But if that's too much to think about, don't worry about it. It's always better to do it on paper anyway, so you can check your work. Now we've finished the left side, but we still need to do the right side. What is 10 to the 9th divided by 10 to the 7th? To solve this, the only thing we need to remember is that when we divide similar numbers with different exponents, we can use subtraction on those exponents to find our answer. So subtract the exponent 7 from the exponent 9. That leaves us with the exponent 2. So our answer now looks like 0.2 times 10 to the 2nd. Is that the answer? Nope. It's not finished because our answer is not in scientific notation. Do you see the problem? Hopefully you see that this 0.2 must be changed. Why? Because scientific notation always has a non-zero whole number before the decimal. So we need to move the decimal to the right one place on the left side, giving us 2. And so that doesn't change the value of our answer, we'll also need to move the decimal to the left on the right side. Moving the decimal to the left means dividing by 10, so all we'll need to do is subtract 1 from our exponent, leaving us with 10 to the 1st. 2 times 10 to the 1st is our answer, which is the scientific way of saying 20. That means that the planet Uranus is approximately 20 astronomical units away from the Sun, which means it's about 20 times further from the Sun than Earth is. Let's do another example of division in scientific notation in our notes. Divide 1.2 times 10 to the negative 3rd by 4 times 10 to the 4th. To solve, divide what's on the left first. Take a quick second to see if you can do this division using some mental math. I found that if I think about 1.2 times 10, which is 12, that would easily be divisible by 4. The answer would be 3. But since 1.2 is 1/10 as large as 12, the answer would have to be 1/10 as large as 3, which means it would be 0.3. If that's not easy for you to do in your head, write it out as a division problem. 1.2 divided by 4 is 0.3. Now let's do the right side. Here we have 10 to the negative 3rd on top of 10 to the 4th. Since we're dividing the same number with exponents, we can just subtract those exponents. Here we have negative 3 minus positive 4. If this seems at all tricky, use a number line. I started at negative 3, and then I subtracted 4. That means I should now be at negative 7. So our answer looks like 0.3 times 10 to the negative 7th. Are we finished? No, we're not. We must move the decimal to the right so that there is a non-zero whole number in front of it. That gives us 3 on the left side. And since we moved the decimal to the right on the left side, we now must move the decimal to the left on the right side. Moving the decimal to the left means that the numbers on the right side would be getting smaller. So should our negative exponent go up or down if that side is getting smaller? Make sure you're thinking of larger negative numbers as getting deeper and deeper into a hole or into debt. So you are getting lower and lower, or the amount you have is getting less and less as a negative number increases in size. So we need to increase this negative number to make the whole thing smaller. So our final answer is 3 times 10 to the negative 8. That's it. You did it. Now it's time to open your textbook. To complete this lesson, start by doing the example problems provided. Try to solve them on your own before you look at the solution and the steps. Once you think you have the correct answer, check your work by walking through the steps, making sure that you arrived at the solution the correct way. Once you are done, you're ready to move on to your homework. See you next time!